All right, thanks for watching and welcome to the second round of Extreme Algebra. Today we will focus on functions and word problems. And by the way, if you're in my Math 117 class, this is the solution of the second practice exam. All right, so let's get started. All right, so first question. Consider this very beautiful parabola f, or this function f, and the goal is to find f of minus 2. So what does that mean? It means if you give me the input minus 2, what is the output? So, and again, to do this, you look at the input and you want to figure out what is the height of f here. And if you go now look at the height, you see it's roughly minus 1. So in this case, f of minus 2 is minus 1. Okay, so not too bad. So let's move on to the second question. All right, question 2. So consider this cubic thingy, so this cubic function. And now we want to do two things. First of all, we want to find x such that f of x equals 3. So this is the opposite of the previous problem. Here, we're given the output and we want to find the input. And so in other words, let's figure out for which points is the altitude or the level of f equal 3. Well, notice there are 2 points at which f of x equals 3. Either it's minus 1 or it's 2. And I believe there's a typo in the answers. So it is indeed x equals minus 1 and x equals 2. So you see here you do the opposite. Here you look at the output 3 and you want to figure out which inputs give you 3. So here f of 2 is 3 and f of minus 1 is 3. And then very quickly, what is f of 1? So which, if you have the input 1, what is your output? Well, here precisely 0. All right, so that was a fun question, but let's move on. All right, question 3, a very fun word problem. So suppose Pablo is putting money in his account and let y be the total amount of money he has in his account. So the total balance, and x, the number of weeks Pablo is adding money to his account. So week 1 would be x equals 1, week 2 would be x equals 2, etc., etc. And suppose his account balance, y, is related to x via the following equation. So y is 350 plus 30x. And the question is, first of all, what is the change per week in the amount of money? And the second question is, what is the starting amount? So you have to understand, when you see such kind of equation, so y equals, in this case, b plus ax, that is a linear function. So basically, the total money changes linearly. So the graph is a line. And what does that mean? So how do we interpret this? So 350, it's the starting amount of the money. So it's the initial balance. And it makes sense because if you plug in x equals 0 here, this disappears and you get 350. So already we know that the starting amount is $350. And then, what is this 30? It's the rate of increase. So in other words, it's precisely the change per week in the amount of money. So in other words, the way to interpret this, Pablo is putting $30 per week into his account. So the change is $30 per week. And it is indeed increasing. And again, to convince you of that, what is the money after 1 week? So it's 350 plus 30 times 1, which is 380. So literally adding $30. What is the change after 2 weeks? 350 plus 30 times 2, which is 350 plus 60, and that's 410. So it's like adding $30 twice. So indeed, it's a linear function. So whenever you see a constant rate, so we're constantly adding money, think of this as a linear function. All right, very good. And again, we'll do a similar problem very soon. So let's move on to question 4. All right, question 4, another fun word problem. So suppose Isabel, she is a salesperson and she sells copies of the book Math for Fun, which I recommend you to read. And suppose her total pay is Y dollars and X is the number of copies she sells. Let's say 10 copies, 20 copies. And suppose her pay is related to the number of copies by 2,200 plus 90x. So again, a linear situation. And there are two questions. What is the change in Isabel's pay for every copy she sells? And the second thing, her total pay if she doesn't sell any copies. So again, remember what is this number? This number is the initial pay when X equals 0. So if she doesn't sell any books, X is 0, so this disappears, and you get 2,200. So her total pay when she doesn't sell any copies, the answer is 2,200. It's kind of like the base pay or the base fee. And then what is this? Again, this represents the rate of change. So in other words, for every copy she sells, she gets $90. And again, to convince yourselves of that, if X is 1, if she sells 1 copy, her pay is 2,290. So 90 more. If X is 2, her pay is 2,380. So 180 more. So you see, hopefully you convince yourself that for every book she sells, she gets $90 more. So again, whenever you see something b plus ax, so blah plus blah x, think of it as a linear function. And again, it represents the case of a constant rate. So here, she constantly gets paid, $90 per book, and the graph is a line. All right, I know this is tricky, so let's do one more of this question. All right, question 5, another word problem. So in this case, Shen is another salesperson who sells Math for Fun books. And assume his base salary is $2,500 and he makes $90 for every copy he sells. And suppose his pay is P, like pay or like Peyam, and the number of copies is C, and assume his pay is related to the number of copies with this function, 2,500 plus 90C. And again, you didn't even need that information because again, we know the base salary is 2,500 and we know that there's a constant rate. So he's constantly making $90 per copy that he sells. All right, and then there are two questions. If the total pay is 5,560, how many copies did he sell? And second, the total pay if he sells 23 copies. So what this is saying is, if P, so the total pay, P, is 5,560, how many copies C did he sell? Which tells you, since you want to solve for C, you have to solve the equation P equals 5,560. So we need to solve 2,500 plus 90C equals 5,560. So that tells you that 90C equals 5,560 minus 2,500. So 90C is, so you subtract that, I think 3060, which tells you that C is 3060 divided by 90. And then you just calculate this, and at the end you find that this is 34. So he needs to sell 34 copies to get the pay of $5,560. Right. I have good news. That was the hard question. Now let's just do the easy question. What is the pay if he sells 23 copies? Well, all we need to do is plug in C here. So in this case, for the second question, the answer is 2,500 plus 90 times 23. And then if you calculate that, I believe the answer is $4,570. Very nice. Again, that's the beautiful thing about linear functions. You can, or functions in general, you can determine the price given the number of copies, and you can determine the number of copies given the price. And here we did both of them, which is pretty cool. All right, let's move on. All right, question 6. So another, not word problem, but a graph problem. So in this case, Eric is draining his aquarium, and the following graph shows the amount of water versus time. And the drawing isn't perfect, but this is supposed to be a line, so it is a linear function. And there are two questions here. First of all, the amount of water initially. Well, to figure out what happens initially, look at time equals 0. So if t equals 0, let's see what the function is. Well, it is precisely 90. So in this case, 90, I believe, liters. Yep. 90 liters. So again, whenever you want to figure it initially, just look where it crosses the y-axis. And by the way, again, side note, this is the b in ax equals b. And then, next question. Okay, so as time increases, what do you think happens to the amount of water? Without looking at the graph, think about the situation. In this case, Eric is draining the aquarium. So as time goes on, I hope that there's less water. Otherwise, it wouldn't be draining. Otherwise, it would be adding water. So in fact, in this case, the amount of water decreases. And how do we know this? Because this line is going down. It's sloping downwards. And one more thing, so at what rate? Well, for this we need to figure out the slope. And remember, the slope is rise over run. So again, it's the amount goes down divided by the amount of time. So here, if time increases by 1, let's see how much it decreases. Well, it goes from 90 to 70, so it goes down minus 20. So the slope here is minus 20 over 1, which is minus 20. So at the rate of minus 20 liters per whatever the units are, minutes. Let me just double check. Well, strictly speaking, it's well, if it's decreasing at a certain rate, so that rate should be positive. So rate of 20 liters per minute. So you can either say it increases at minus 20 liters per minute, or it decreases by 20 liters per minute. The point is, it's going down. All right. So sure, you're tired of word problems, so let's do a little algebra problem now. Okay, here let's solve for y in the equation minus 2 over y equals 8. So hopefully this is not too bad, because one thing you can do is simply cross multiply. So cross multiply this and this, because technically 8 is 8 over 1. So what you get is minus 2 times 1. So minus 2 equals y times 8. So 8y. And so 8y is minus 2. And so y is minus 2 over 8. And that's minus 1/4. So that is the answer here. All right, that was a cute math cookie, so let's move on. All right, another cute algebra problem that you can solve essentially using the same technique. So here, minus 5 over w minus 3 equals 6. And again, same trick as before. You can just cross multiply, and you get, so minus 5 times 1. So minus 5 equals 6 times w minus 3. Careful, the minus just goes with one of the two. Don't put it with both of them. And then what you get is 6 times w minus 3 equals minus 5. And remember, our goal is to solve for w. So let's divide by 6 here. And then we end up, this cancels out. And we end up getting w minus 3 equals minus 5/6. And lastly, just add the 3, so w equals minus 5/6. 5/6 plus 3. And then the question asks to simplify, so let's just put it on a common denominator. So minus 5/6. 3 is, I believe, 18/6. And at the end, you get, again, minus 5 plus 18. 6, and I believe that gives you 13/6. Not a nice answer, but what can we do? All right, after this algebra, let's go back to word problems. All right, so the next 3 problems, unfortunately, they are word problems, but they're still very important. So, suppose that there is a theater group that makes appearances in 2 cities, A and B. I like to call them Peyamgeles and Algebraville. And suppose the hotel charge before tax in the second city is $1,000 higher than in the first city. At this point, stop, because we already have some information. We know that B, in other words, the charge in B, let's call that B, it's $1,000 more than A. And we'll use this in a second, okay? Then, we know the tax in A is 4%, the tax in B is 8%, and the total tax paid is $710. And the question is, what is the hotel charge before tax in each city? Okay. Now, we already have this info that B is 1,000 plus A, but now the tax in A is 4%, which is just 0.04 times whatever you paid in A, and the tax in B is 0.08 times whatever you paid in B. And we also know that the total tax paid is $710. Now, what is the total tax paid? Is the one that you paid in A plus the one that you paid in B. So what we know is that 0.04A plus 0.08B is 710. And as Archimedes would have said, Eureka, because we don't need words anymore. We already have our 2 equations, and we just need to solve for them. All right. So what do we know? On the one hand, we know that 0.04A plus 0.08B is 710. And we also know that B is 1,000 plus A, which is fantastic because you can just plug the second equation in the first equation. You see? Because here we have a B, but we know that B is 1,000 plus A. bzzz, like a bee. And then, so we know that 0.04a plus 0.08 times 1,000 plus a is 710. But now the nice thing is you can distribute that. So we still have the 0.04a. Now, 0.08 times 1,000, I believe that's 80, plus 0.08a, that's 710. Now, those two things, you can combine them to get, so 0.04 plus 0.08, that's 0.12. And this 80, you can put it on the right-hand side to get 710 minus 80. And let me see, that's 700 minus 70, I believe 630. Okay. And so 0.12a, that's 630. And this gives you a is 630 divided by 0.12, and you can either do the algebra or you can use a calculator. Either way is fine. So 630 divided by 0.12, that gives you 5,250. So 5,250 in city A before tax. And the question is, what about the price in B? Well, remember, B is just 1,000 plus A. So to figure out B, you just add 1,000 to this price. So 5,250 plus 1,000, and you get 600,250. Now, I believe that's correct. Let me just double check. Correct. Yeah. So again, I know those word problems are tricky, but you always have to ask yourselves, what information does every sentence give me? And then once you transformed everything into math, then the rest is just math. So you just solve the equations. All right, that was part one. Now, second of 3 word problems. All right, so next question, another word problem. So suppose you're at the movie theater and the child admission is $6.60 and adult admission is $9.90, which makes me think this must be the 90s or something for such a cheap price. And then 3 times as many adult tickets as child tickets were sold on Wednesday, for a total price of $1,197.90. And the question is, how many children's tickets were sold that day? All right. So I would say let's start with the total price. Okay. So the total price, we know that it's $1,197.90. But how do you get that? You get it by having the children's admission, so 660, times, or if you want 6.6, times however many children's tickets were sold, plus 990 times whatever adult tickets were sold. However, and that's the nice thing, this is not too bad, we know that 3 times as many adult tickets as child tickets were sold on Wednesday. So basically, we know that the number of adult tickets is 3 times the number of children's tickets. In other words, A is 3C. Which tells you we can just plug in A equals 3C into this equation here. So, and the nice thing is we don't need any other information anymore. Because you see, you parse through the sentences and you just transform every English sentence into math. So what you get is 6.6C plus 9.9 times 3C equals 1197.90. And then, if you want, first do that algebra. Yeah. So 9.9 times 3, that's 29.7. So 6.6c plus 29.7c equals 11997.9. And then you can add that up. So 6.6 plus 29.7, that's 36.3. C equals 1197.9. And again, remember in my class, calculators are allowed, so it's normal. Otherwise, we would have given you nicer numbers. So C is 1197.9 divided by 36.3. So 1197.9 divided by 36.3, which gives you 33. So 33 children's tickets were sold. Okay, let me just double check. Yes, okay, that works. And by the way, if they ask you about the number of adult tickets, you would just multiply that by 3, because 3 times as many adult tickets were sold. All right, one more word problem left, and then we can move on to more fun algebra. All right, let's move on with the third and last word problem. But before that, a very sad story. So I actually recorded questions 11 to 30, and it took me like an hour, but my phone heated up and actually didn't record anything. So now, hopefully this time it works. So this time Tony is investing money into 2 investment funds, A and B, and in fund A, he's investing $2,000 and gets a 2% profit. And in fund B, he invests some amount of money and gets a 5% profit. And the question is, how much exactly did he put in fund B if we know that the total profit is 4%? So again, just like usual word problems, you just parse through every sentence. So we know that in fund A, there's $2,000 and a 2% profit. So the nice thing is we can already figure out the profit in fund A. So which is 0.02 times 2,000, which I believe is 40. Okay. And in fund B, we don't exactly know how much money there is, but if he invested B dollars, the profit would be 0.05 B. So in other words, what is the total profit? It's the profit from A, which is 40, plus the profit from B, which is 0.05 B. So we know that this is 40 plus 0.05 B. On the other hand, we also know that the total profit is 4%. So it's 0.04 times the total amount of money he invested, which is what? $2,000 from fund A plus B dollars from fund B. Bzz, like a B. And then the nice thing is, from this equation, we can actually solve for B, because we get 40 plus 0.05 B equals, so distribute this out, 0.04 times 2,000, that is 80, plus 0.04 B. Okay, and let's sort of play around with this. So then what do we get? So we can put this 40 on the right-hand side and the 0.04 B on the left-hand side to ultimately get that 0.05 B minus 0.04 B equals 80 minus 40. So 0.01 B equals 40, which ultimately tells you that in fund B, there is 40 divided by 0.01. And hopefully you are not using your calculator to calculate this, because this is the same thing as 40 times 100, which is 4,000. So ultimately, Tony had $4,000 in Fund B. And now we're done with our word problems. Hallelujah. Now let's move on to equations, much easier. So let's solve for u in square root of u minus 7 equals 25. And remember, in order to undo a square root, you just need to square. So this thing squared equals to this squared. But what is square root of u minus 7 squared? That's just u minus 7. Okay. And what is 5 squared? That is 5 times 5, and that's 25. So in other words, u becomes 7 plus 25, which is 32, which is my age. Very weird, just to remind me that I'm old. And what do I want to say? By the way, I can't resist, but let's put a little uvu here. All right, next question. One of the easiest questions for today. So solve for y, where square root of y equals 6. Again, same spiel as before. So you're squaring both sides. And then square root of y squared is just y. 6 squared, that's 6 times 6. And that's 36. Very nice. All right, next one. So now let's solve for w in absolute value of 6w plus 3 equals 15. And it's very, very important. If absolute value of this equals 15, it means two things. Either 6w plus 3 equals 15, or 6w plus 3 equals minus 15. So super, super important. If, let's say, absolute value of x is 4, it could mean that x is 4, but it could also mean that x is minus 4. Because if you take absolute value of minus 4, it's still 4. So very important. If absolute value of a number equals 15, that number is 15 or minus 15. And so we have two separate equations to solve. So we get 6w equals 15 minus 3. So 6w equals 12. So w is 12 over 6, which is 2. Or 6w equals minus 15 minus 3. So 6w, it's minus 18. So w is minus 18 over 6. So w is minus 3. Which tells us that there are two solutions. Either w is 2 or it is minus 3. Okay. So yeah, very important with those absolute values. It's either that number or negative that number. All right, moving on. All right, so now let's find the domain of a function. More precisely, let's find the domain of u of x equals square root of 6 plus x. First of all, what is the domain? It's the set of numbers for which the function is defined. For instance, is the function defined at minus 8? Well, u of minus 8 is square root of 6 minus 8, which is square root of minus 2, which is not defined in our course. So your calculator would give you an error or some weird i's. And so the question is, for which x is this valid? And all we need to figure out here is, for which x is the number under the square root non-negative? And so in other words, for which x is 6 of x, 6 plus x, greater or equal to 0? Well, it's precisely when x is greater or equal to minus 6. And of course, the next question is, how do you write this in interval notation? So again, very important. It starts at minus 6, and you want all the numbers greater or equal to minus 6. Now, because we have a greater than or equal, we need to include minus 6. That's why we put this word bracket. And what we want to say is all the numbers up to infinity. But very important, infinity is not a real number, so we're excluding it. So with infinity, there is always a parenthesis. And that's our domain. Ta-da! Again, we're including minus 6, but excluding infinity. All right, very good. We're now halfway done, so 15 questions to go. All right, again, similar in spirit. Let's find the domain of h of x, which is square root of minus x plus 2. So here again, you want the number under the square root to be non-negative. So you want minus x plus 2 to be greater than or equal to 0. So you want a minus x to be greater or equal to minus 2. And very important, whenever you flip the sign, you have to flip the middle part as well. So if minus x is greater or equal to minus 2, this tells you x is less than or equal to 2. So that is the domain. And again, the question is, how do you write this as interval notation? So again, this is 2, and you want to see everything less than or equal to 2. In this case, you start with minus infinity. And again, you always put parentheses with plus or minus infinity, and you go all the way up to 2. And because it's a less than or equal sign, you include the 2. So you put square brackets. All right, very good. And then just a couple more domain questions. All right, now let's find the domain of square root of x plus 8 over 3x minus 10. So here we have two things to watch out for. On the one hand, as usual, we want the number under the square root to be non-negative. So here we want x plus 8 to be greater or equal to 0. So x is greater or equal to minus 8. On the other hand, we want the denominator of a fraction to be non-zero. So you can never divide by 0. It's a big boo-boo. So let's make sure this denominator is non-zero. So 3x minus 10. That's not equal to 0. This implies that 3x is not equal to 10. So x is not equal to 10/3. And now let's summarize what we have. On the one hand, the domain is all the numbers greater or equal to minus 8, except you exclude 10/3. So basically, all the numbers in this region, except this big bubble at 10/3. And the question is, how do we write this in terms of intervals? Notice this has two pieces, the left piece and the right piece. So the way to write this is as follows. Remember, because you have a greater or equal sign, you include minus 8. You put a bracket. So minus 8, comma, 10/3. But you're not including 10/3 because we want x not to be 10/3. Or this piece, so 10/3, again, you're excluding it, and then infinity you just exclude anyway. And the question is, how do you say this piece or this piece? You write this little u. U means or. So that's the domain. All the numbers from minus 8 to 10/3 or 10/3 to infinity. So that's the domain. Okay? Again, u means or. All right, let's move on with a similar exercise. So now, a surprise double question, which we all love, right? Let's find the domains of those two functions, x plus 3 over x squared minus 9 and x over x squared plus 64. So here, we just need to figure out when is the denominator non-zero. Okay? So for instance, x squared minus 9, let's figure out when this is 0. Well, this is the same as x squared equals 9. And remember, if the square of a number is 9, it means that number is plus or minus square root of 9. So plus or minus 3. So what is the domain? It's all the numbers other than plus or minus 3. So in terms of a picture, it looks as follows. again, all the numbers except we exclude plus and minus 3. And so notice there are in fact 3 pieces here. And that's how you write the domain. The first piece is minus infinity comma minus 3. And again, you always exclude minus infinity and you exclude minus 3 here. Or the middle piece. Remember, or you write this with a u. Minus 3 comma 3, which again you exclude, or 3 comma infinity. And that's the domain of the first function. And now let's look at the domain of the second function. Well, we want x squared plus 64 to be non-zero. So let's figure out when this is 0. So x squared equals 6 plus 64 equals 0. That means x squared is minus 64, like Nintendo 64. But notice this can never happen, because x squared is positive or greater or equal to 0. So how can a positive number be negative? So how can a positive number be minus 64? That doesn't work. So what does that tell you? It tells you that the denominator is never 0, which is very good, because in other words, this function is actually defined for all the real numbers. So here the domain of g, again you can write this several ways, either all the real numbers, or you can write this as minus infinity comma infinity. So it's defined everywhere. That's nice. So again, that was the domain of f, and that was the domain of g. All right, and those are all the domain questions for now. So let's move on to line stuff. Okay, so let's do a quick line question. So let's find the slope of the line passing through those 2 points. So minus 8 comma minus 3 and minus 3 comma 4. So you don't need to draw a picture, but just for aesthetic purposes, let me draw it. So minus 8 comma minus 3, maybe it's here. And then minus 3 comma 4, maybe it's here. Okay. So kind of this line. And the question is, how do you find the slope of the line? So it's always rise divided by run. In other words, how much did the line go up divided by how much did you go to the right? So here the rise is just 4 minus minus 3. Because you see it went from minus 3 to 4 divided by minus 3 minus minus 8. Because we went from minus 8 to minus 3. So in the end, what this becomes, it's 7 over minus 3 plus 8, which is 7/5. That's just the formula for the slope of a line. All right? All right, next question. In my opinion, one of the easiest questions of this extreme algebra round. So the equation of a line in slope-intercept form with slope 1/3 and y-intercept minus 3. So what is the slope-intercept form? It's y equals to ax plus b, where a is the slope and b is the y-intercept. And here we give you both of them, so that's kind of nice. So y, in this case, the slope is 1/3, and the y-intercept is minus 3. So the answer is 1/3 x minus 3. Not bad, huh? All right, next question. So a line passes through the point 8 comma minus 5 and has slope 3/4. The question is, what is the equation on the line in slope-intercept form? So again, slope-intercept form means y equals to ax plus b. But remember, a is the slope, so we already give you that. So y equals to 3/4 x plus b. And again, many ways of doing this, but in my opinion, the easiest way is just plug in x for 8 and y for minus 5 for y. So in this case, y is minus 5, and then x is 8. So that just means it goes through that line. So in other words, the equation we have is minus 5 equals to 3/4 times 8 plus b, which you can just simplify to minus 5 equals, so 8 divided by 4 is 2, times 3, that's 6. And then 6 plus b is minus 5. So b is minus 5 minus 6, and that's minus 11. So what is the answer? Maybe let me write this here. Y is 3/4 x minus 11. And you can always check, by checking if it goes through the point. So if you plug in 8 here, you get 3/4 of 8, which is 6. And if you subtract 11, you get minus 5. So that's good. All right, next question. The next 3 questions have to do with inequalities. So let's solve for x in 1 is less than 6 plus 5x. So let's isolate x. So what we get is 6 plus 5x is greater than 1. Okay. Convince yourself that this is the same inequality. And then let's put 6 on the right-hand side. So 5x is greater than 1 minus 6. So 5x is greater than minus 5. And the important thing about inequalities is you only have to change the sign if you divide by something negative. So here you're dividing by a positive number 5, so you don't have to worry about anything. So in other words, what you get is x is greater than minus 1. And that's it. Okay. All right, next question. So in this case, 15 is greater or equal to minus 5 minus 5y. That's the same thing as minus 5 minus 5y is less than or equal to 15, if you read it from right to left. And then let's put the minus 5 on the other side. So like Adele says, hello from the other side. So minus 5y is less than or equal to 15 plus 5. So minus 5y is less than or equal to 20. And now be super careful. Now you're dividing by a negative number. You're dividing by minus 5. Which means you have to change the sign, because minus 5 is negative. So, and you're left with y is greater or equal to minus 4. I believe that's correct. This time solve for w, in 2 minus 9w is less than or equal to 14 minus 6w. So again, just a way of, just shuffling around a bunch of things. Put the 2 here and put the minus 6w here. And then you get minus 9w plus 6w is less than or equal to 14 minus 2. And that gives you minus 3w is less than or equal to 12. And now you're dividing by minus 3. So again, because you're dividing by a negative number, you have to switch the signs. So what you're left with is w is greater or equal to minus 4. All right, very good. So that was the last inequality question. And now let's move on to, not word problems, but you'll see what I mean. All right, here a word problem, but only the math matters here. So suppose you have a photocopy service that charges you a base fee of $11.75, and per copy it charges you 8 cents, so $0.08. What is the cost of 50 copies? Again, here the function is the cost of making x copies is 0.08x plus 11.75. Well, the cost of 50 copies, so C of 50, is 0.08 times 50 plus 11.75. And I believe this becomes, so 0.8 times 5, I believe this becomes 4 plus 11.75. So in the end, just $15.75. Not too bad at the end. I know it's a word problem, but it's not bad. All right, next question, very similar. So next question, suppose you have a plant that's initially 45 centimeters high, and each month it grows by 1 centimeter. And in particular, the height after m months is 45 plus m. And the question is, what is the height after 12 months? So if the height after m months is this, the height after 12 months is just h of 12. Which is 45 plus 12, and that becomes 57 centimeters. I don't really know that problem because my plants, they always die after a month, so that's a very interesting math problem to me. All right, almost done. So next question. All right, next question, very interesting. So if f of x is 3x squared minus 2x, what is f of x minus 5? All this means is that for every instance of x, replace it by x minus 5. So this becomes 3 times x minus 5 squared minus 2 times x minus 5. And here all you need to do is to use the identity a minus b squared. It's a squared minus 2ab plus b squared. So this becomes 3 times x squared minus 2 times x times 5 plus 5 squared. And then here minus 2x plus 10. Okay. And this becomes 3 times x squared minus 10x plus 25 minus 2x plus 10. And then you expand this out. So 3x squared minus 30x plus 75 minus 2x plus 10. And then minus 30x goes with minus 2x, and 75 goes with 10, and this becomes 3x squared minus 32x plus 85. Ta-da! All right, the next question is similar in spirit. Here, f of x is 2x squared minus 2, and let's calculate f of 4n. It seems very 4n to me. Like 4n? Anyway, so again, same thing as before. If you plug in, all you need to do is for every instance of x, replace it with 4n. So this becomes 2 times 4n squared minus 2, and that becomes 2 times 16n squared minus 2, and that becomes 32n squared minus 2. Man, what's with all the 32s? Just making me feel bad. All right, 2 more questions. And of course, it's a 2-part question. Who knew? So here, f of x is 4x plus 3 over 5x plus 2. Let's calculate f of 5 over x. So again, same spiel as usual. So you replace every instance of x by 5 over x. So 4 times 5 over x. 5 times 5 over x. So this becomes 20 over x plus 3 over 25 over x plus 2. And then you just put it on a common denominator. So this becomes a 20 over x plus 3x over x, and then 25 over x plus 2x over x. And they say don't talk about your x's, but here lots of x's here. So we get 20 plus 3x over x over 25 plus 2x over x. And the nice thing is, those x's you can cancel out. So if you want, you can also flip it and cancel everything out. And you're left with 20 plus 3x over 25 plus 2x. Which you can totally also write as 3x plus 20 and 2x plus 25. There we go. Doesn't matter. Okay. Both of them are valid. All right, well, part B, So here g of x is square root of x squared minus 8x, and calculate g of x minus 3. Again, replace every instance of x here by x minus 3. So we get x minus 3 squared minus 8 times x minus 3. So same rule as before. It's a squared minus 2ab plus b squared. So here we get square root of x squared minus 2 times x times 3 plus 3 squared. And here you expand it out, minus 8x plus 8 times 3, which is 24. And this becomes, again, square root of x squared minus 6x plus 9 minus 8x plus 24. And so minus 6x minus 8x, that becomes minus 14x. So x squared minus 14x. And then 9 plus 24, that becomes 33. Okay, and then one more, and then we're done. Last question, not too bad. So we're ending on a, not on a high note, but I guess on a low note. So g of x is x minus 9 over 3x plus 3. So and then g of 5, again, we replace every instance of x by 5. So 5 minus 9, and then 3 times 5 plus 3. And that becomes minus 4 over 15 plus 3. And that's minus 4 over 18, which I believe you can just simplify to minus 2/9. All right, and that's it. Thank you for surviving the second Extreme Algebra Challenge. I hope you liked it, and if you did, please make sure to subscribe to my channel. Thank you very much.